So far, you have been brought up with the Cartesian grid system, but what happens if you come across a problem which cannot be solved directly with the use of Cartesian coordinates? As engineers, we must think outside the box and use other methods to address such problems. Polar coordinates allow us to think in terms of angles, curves, and spirals rather than linear lines. Polar coordinates have even been used to model the grid of some flowers and shells. What exactly are polar coordinates? Some shapes, like the heptagon, can be hard to represent on a Cartesian grid. Therefore, we can use polar coordinates to help us simplify this process. We all know how to represent a point on a grid using Cartesian coordinates x and y. This can also be done with polar coordinates, which requires two parameters. We must know the length of a line from the origin along the x-axis, and the angle we will rotate this line by counterclockwise, measured in radians. If we were to represent the same point with both Cartesian and polar coordinates, we find the following relationship. By comparing the sine and cosine of the angle, we find that x is equal to r cosine theta and y is equal to r sine theta. We can now convert back and forth between polar and Cartesian coordinates. Going back to our heptagon, we can simply define r as any length. We know the inside angle is 2 pi over 7 radians. We can simply go along the vertices and plot points in polar coordinate form, after which we can convert back into Cartesian form using the rules we have just learned. This makes representing heptagons a lot easier than guessing the points.